Hello and welcome to the video. When I was first learning Python, one of the things I used to do to try and improve my skills was have a go at rebuilding a lot of the basic built-in functions from scratch, and this video is going to do just that, and we're going to be looking at the sum function today. So what we're going to do is we're going to look at how the built-in sum function works. We'll look at the exceptions that are raised if you pass in some incorrect arguments. We're then going to build it from scratch and then put our own twist on how the function works. So to start off with, let's look at how sum works. I'll just zoom in slightly here for you. So if I define x as a list equal to 1, 2, 3, 4, let's get these nice and spaced out. And then if we say y is equal to sum of x here, let's just quickly print that off underneath and see what we've got. So we print y, hit run, and we see 10 here. It also takes an optional start parameter as well. So say if I pass in, let's do 10 for example, if I hit run this time, see how it now comes out to 20. Basically what this does, this effectively says start counting from this, add these all on and then return it. But you can basically see it as give me the sum of this plus this here. You seldom use this, but it's worth noting that it's here. And of course there's many ways that this could go wrong. Let's actually tell you what, we'll leave start here as 1. Suppose for example if I pass in, let's do a for example, that's going to go wrong because it doesn't know how to add this string of a to these integers. That's one way you can break it. If you pass in the string version of 1 here, that's also going to break it as well. So when we're building our own version of the sum function, we need to make sure that we handle these edge cases correctly. And what we'll do, we're going to raise our own custom error to basically say what's gone wrong. So without further ado, let's clear the screen and then we'll have a go at building this from scratch. To begin with, we're going to write def, so we're first going to define our function here. And now you could do this, not a good idea, because then we'll be redefining sum. What we could do is do sum func like this. This makes sure that the original sum function stays as it is, so we can use both and then compare them at the end. Now, our function is going to first take in some sequence. Let's just presume for the time being that it's going to take in lists and tuples only. So what we're going to do, we're going to write seq here. This is short for sequence. And then what I'm actually going to do is use the typing module to specify what our thing takes in. So in this case, if you just see sequence, it's a bit ambiguous as to what sequence actually is. So if you do from typing, let's do import union like this. And what this does, if I write this here, if I write list or tuple like this here, we're basically saying that the sequence we pass in, that can be a list or a tuple. Let's then do our optional one here at the end as well. So in terms of what this is going to return, this can return an int or a float. So of course, if you've got floats in your sequence, it's going to return a float. If they're all integers, it's going to return just an integer. Let's just quickly do some ellipses and check that it runs without any error. And it does. Let's handle our start parameter as well. This is going to be optional. So if we do start, so if I just do start equals 0 here, this implies that it's optional. But we also want to make sure that our user is aware that this can be of different types as well. So to do this, we're going to do start, colon, and we're going to say int or float here. But we're saying it starts off its life as 0. So I'm going to just quickly come down here and do sum func and open this up. So you can see, because we've done these type hints, a VS Code is telling me that the sequence we pass in, that can be a list or a tuple. That start parameter, that's optional, it's already set to 0, but that can be an integer or a float. This function is also then going to return an integer or a float here. Now you could do this in a bit more of an advanced way, but just to keep it simple for the time being, I would argue that this is good enough for the time being here. What we then want to do is just do a basic doc string. So if I just do, and of course if you're doing this yourself, I'd make this a bit fancier, but for now I'm just going to write return the total of sequence, I'll do CEQ for short like that, plus the optional start param. In practice, you generally make these a bit bigger, a bit more detailed, but that's fine for the time being. And now what we can do, if we do sum func again like this, we can see that our doc string now appears here, which is pretty good. And if you're new to code, I'd highly recommend putting these in, even if they're just really simple and really basic. Especially if you're writing code and then revisiting it a while later, just having this simple kind of one-liner to say, hey, here's what this function does. It's very useful, and I try and do these in every function I write, even if the code is just for me. So the next thing we're going to do is start to build out the logic of our function. So let's see, I'm first going to define an array x, or a list x, let's just say. Let's just do 10, 20, 30 here. And we're going to just pass this in to our sum function and then get results back on the other side. And we'll do this kind of as we're doing it. So rather than doing the whole function and testing it, we're going to be very iterative and test it as we're going along here. So we define x, we're then going to say y is equal to sum func of x, just so we can return it here. And then we'll just then do print y underneath here. Now the first thing we want to do is just kind of have an idea for how this is going to work in our heads. Basically what we're going to do, if I move this down here, we're going to keep like a temporary variable. Let's just call it k for the time being. And we'll set k equal to 0. We're then going to write a for loop to iterate over the input, in this case, seq. We're going to say, for each item in the input, take it and add it onto k here. So you imagine that k starts at 0. Our for loop then says, for each item in this, add onto it. So we first come to 10, and we do, okay, to 0, add 10. K now becomes 10. Then hop to 20 and say, add this to k. So 10 plus 20 now becomes 30. Finally, we hit the last item in the list, which is 30 itself. We add this back onto k, and then we're done. Then what we'll do at the end of the function is we're going to say, okay, return k plus whatever start is. So if a user passes in nothing for start is, that's going to stay at 0, so we just return 60. But say if our user passes in 10, it's then going to say return k 60 plus 10 to get 70. So we're going to use a for loop and a variable to keep track of our current total. So let's build this out. Let's define a variable total equal to 0, and then our for loop is then going to say for each item, so I'll do for none in sequence, go to that total variable, which we've defined on line 7, and add on to this none. And then at the bottom, once the for loop is finished, we can then do return total. So as a minimum product, this works. So if I hit run now, we get 60, and that's absolutely fine. Let's now do return total plus start here. So right now we've not passed anything in, so start is equal to 0, and we get 60, and that's absolutely fine. Let's do start is equal to 5, so if this all goes to plan now, we should get the total of our list, and at the end we'll say return that total plus whatever that starting parameter was, and we get 65. Okay, that's pretty good. Now, where things fall apart is if I now come along and do, okay, 1 as a string, and now we get a type error. And what we're going to do, we're going to be a bit fancy here. We're going to create our own custom error class and then raise it whenever this happens. And to do that, I'm going to make the screen a bit smaller for a second. I'm going to create my custom error up here. So if you do class, and then I want to give my error an appropriate name. So I'm going to call this some error, like this. And we have to make it inherit from exception. That means that we can use the raise command with it. So if we do raise some error, we can do that because the built-in exception class has that capability, which we're inheriting from. And a quick doc string, so let's say, we'll say raised when an error arises. Let's say during summing, there we go, just like that. Cool, and we can leave it like that, that's absolutely fine. So what we're going to do, we're going to look at where this error is raised, and we're going to say, if this happens, raise this instead, okay? And this happens here, total plus equals num. So when it's iterating through, it finds this one, tries to add on to total, and says, you can't add this string to this integer. And that's what this is all about here. So we're going to say, let's catch it. So we'll say, try and add num to total. However, if you happen to catch a type error in this case, if I do type error here, accept it as exe, and this exe does something really important. This exe basically captures this string here, and we can say, if a type error happens, raise a sum error, and then if I give it exe like this, we should get a different kind of situation now. So if I hit clear and run, we get this sum error. So we can see that we're now raising our own custom error here. And again, because we did accept type error as exe, we took that string, which basically says this, and we said raise the sum error and pass it exe. So basically we can see that kind of raw output in the console here, which is really useful, which gives us a better indication as to what's happened. So we can see, in this case, we tried to do the incremental operator, but we tried to do it with an int and a string, and that's why it went wrong. Just to further test it as well, if I do clear, let's just quickly remove this out of the way, and it should work now with no faults. 65, there we go. Now, the last thing that could potentially go wrong is someone doing something like this. So imagine we pass in a string. We also don't want that to happen, and that's happening down here. So what I would probably suggest doing for this is checking this at the very beginning, and the way to do that is to use the isInstance function. So, but we're going to flip it. So if I do if not isInstance, and we're looking at start here. So what this is basically going to say, we're saying if this is not an instance of something, 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 do X, Y, Z. So it's quite worded that. So let's just build it up and have a look. So if I do int float, just do this here. So basically what this is going to do is this is going to say if the starting parameter is not an integer or a float, then do this. And what we can do is just take that raise statement again. So raise a sum error, and let's say start must be an int or a float here. And that looks pretty good. So sum error start must be an int or a float here. You could take it a step further. Let's make this an f string. So if I did not, and then in this case, if I did type of start here, let's see what we get. Start must be an integer or a float, not a string. So yeah, of course, there's many ways you could do this, but in my opinion, this is the best way, because if you pass in something that's incorrect for the start, then there's no point doing all of this and it crashing here. We may as well check this at the very beginning, and then if we're happy, then we can say, okay, cool, this is definitely an integer or a float, therefore come along, have a go at doing this with your built-in error checking, which raises our custom error, and then if that's all good, we can go ahead and actually calculate the sum here. The last thing to do is just to compare this to the built-in sum function. So the way to do this, I'm actually going to print y, and then also print the sum of x here. And we basically want to see it do the same thing. So let's remove start and check that we get the same output for both. 60, 60 and none. I also shouldn't have done print here. I can just do sum of x like that. That's fine. 60, 60, that looks good. Let's try start as -1. And then we'll also do start is equal to -1 here. Check that they both behave the same, and they do. So there we are, guys. That's it. And so if you're, of course, learning Python from scratch, I'd highly recommend having a go at this, and maybe try and get some other functions as well, such as min, max, len, etc. But yeah, I hope you enjoyed the video, guys, and I'll see you all in the next session.